guys, welcome back. Today's we are here with another offer again. In the previous session, through the live, we gave a job offer for one person. Tomorrow he's going to come with an offer letter. Yes, tomorrow he'll be coming with an offer letter. Today he's on the way. Right now, today's offer, it's not a job offer. Let him come and let's hear from him what is his opinion. Okay, then we'll call for the next offer. Okay, so yeah, Tarun is saying please extend. Yeah, sure, Tarun, we'll extend a GENCO validity at free of cost. You're asking us to extend, we'll extend if my this month expenses are borne, my this month expense of the studio expense, at least studio expenses, not any other expenses. If my room owner, if this flat owner waive off this today's month expenses, we'll extend it for free. Okay, or if you can come and serve us for 1 month for free of cost, we can extend your course for free. Or if your government can waive off some of our taxes, we will extend your course for free. Okay, if any one of these things, if you make sure it happens, we'll extend it for free. Okay, absolutely free. So please recommend PiSquare Academy to your whoever the government, then we'll do it. Okay. Anyway, that's the stupidity here. You're paying per semester 60,000 you're paying in your college to learn 6 subjects. Here, with amazing animations, we are giving you the course for 2,000, 1,800. If you can't pay 1,800 for your career to crack the job which you want, why you want assistant engineer job in TSGENCO? Let's not get into that. I know you guys are crazy. You want free. Free, I'm saying, right? Whoever wants it for free, ask us in the chat, sir, I want particular course for free, video course for free. We will send you the free resources, materials we'll send you on the WhatsApp. We're sending you. Our bots are there, always waiting for you. Whenever you send that, I want a free material of these subjects. If it is available in the web, we are sending you the direct free videos, free forever, not till the, GENCO exam. So if you want PiSquare courses to be free, that you should not say that at all. Say your course free, say your heart free. What is this claim? These are stupid claims. I think for fun you're asking, it's stupidity of mine to explain all of this stuff. But I just want to let you know, when we hear these terms. Tarun, I think he's one of the person who is looking for the job. Come on, yeah, Tarun. You are one of the guys who selected out of all those 4 options, but you're not eligible to 2014 password, I think you are. So because of that, you're not you're not going for the interview. Okay, because they want, for tomorrow's interview, they want 2023 pass out and 22 pass out. That's it. Okay. Anyways, Tarun, will you serve PiSquare Academy 1 month for free? I just want to know your opinion here. Will you serve 1 month for PiSquare Academy for free of cost? Tarun Kumar? If yes, I'll book a flight ticket right away, just right now, from your place to yes. Sure, thank you, my dear. I'll extend the course for free. Okay, so tell me what's your location right now. You can come to Bhubaneswar. You're already in the job. How much salary do you? What's the salary you're doing? What's the salary you're getting? Free of cost, you're working somewhere? Are you working free of cost somewhere? 5 lakh salary. So 5 lakh salary is good enough, right? Why you're aiming for 6 lakh salary? Why you're aiming for 6 lakh salary? Because you feel you're not 5 lakhs worth. You're 10 lakhs worth. You deserve 10 lakhs. So you should aim for that. Anyways, let's come to a point. Slightly it got deviated. Sorry guys. Anyways, Tarun, I think he's also not taking seriously. Okay. On a lighter note, we're talking all these. Yes. Subbu, let's begin the show. Let's begin the show. Sometimes when some people, out of their interest and all, out of their love towards extending the validity and all, when they ask these questions, I'll get triggered. Okay. Because I think for you, I just want to play a snapshot for some time. Okay, maybe for 10 more seconds. Let me just play, what is a PiSquare style. I think those who don't know PiSquare style, including Tarun, just watch it once. Yeah. Now tell me if somebody in the world who is teaching electrical engineering just the way he has seen 10 seconds back, show me that, I will give free. I'll give TSGENCO, I'll extend TSGENCO validity for free. If somebody is doing, even at 40,000, you are ready to pay 40,000, somebody in the world who is teaching electrical engineering in that fashion to you, I'll extend TSGENCO validity till the time you want free. Moving to the first question. Today we got some interesting questions. Today we have got some really interesting questions. Let's see. So this question, it looks difficult, but it's really easy. Transformer questions. We are here with transformer questions. Okay. And this one, let's see how you're going to answer these questions. Okay. Let's get to the first one. First question. Here you go. I think I should run the timer also. Timer is running. 1 minute timer for the first question. Bang. Yeah, Tarun is one of our regular students. See, he already answered. Next time, guys, my point is, don't beg anyone for anything. Don't be a beggar. Time's up. It's asking. Okay. Okay. See, for free, when you're asking for free, it's... Anyways, your definition is different and my definition is different, I think. I'm just saying, if it is asking, it's fine. You're asking. But I'm saying, don't beg anyone. In an interview, if you go to an interview, don't beg for a job. In an interview, if you go for an interview, don't beg for a job. Show your potential, bag the job. It's not that he is offering you the job. You are fulfilling his requirement. Right now, why companies have approached us for students, tell me? They are begging to fill their positions. Why, tell me? They are begging us. As an aspirant, you should not beg for the job. You should bag the job. You should have that caliber. Yes, I can fulfill this position. I am this. I want this much salary. If you can give, I'll get in. Otherwise, I'll not go. There are some amazing people. They will select the company. It's not the company selects them. They will select the company. You should be in that position. Okay. I think, yeah, when you have that confidence, when you have that knowledge, you will be rock star. Okay, I hope you'll be one of them. Anyways, we're completely off tracking. I think something got tripped. No load losses on the transformer carried out to determine. Guys, we have one video about this OC test. I think everyone knows this. Why OC test conducted on low voltage winding? Can you give me the answer? Anyways, I think that's the next question. We'll get to that. So for this, no load test on the transformer is carried out to find out magnetizing current, yes, I mu, and no load losses, yes, these two are correct. These two are correct. Efficiency, we cannot find out from the no load test. For finding out efficiency, tell me what are the tests you require to conduct? No load test and tell me. And short circuit test. These two tests you should conduct to find out the efficiency. If you go for no load test, only magnetizing current and no load losses. That's it. Okay. So I'm moving to the next question. So here, I want your answer. Durga Prasad is saying at low voltage side core losses are less. Come on, yeah, that's not right, Durga Prasad. But it's a good try. It's a good try, Durga Prasad. But that's not correct answer. If you want to know what is the correct answer for this question with a detailed and amazing explanation, which nobody knows it. Yes, I mean it. Nobody knows it the right reason. Everybody go after some crazy reasons. But in the YouTube channel, in our Y series questions, why 11 kV, why 50 hertz, why kVA, this series question, one of our popular series questions, there I have explained why OC test is conducted on the low voltage side. That is clearly explained. Okay, not because of the core losses and all. Yeah, look at this. Time's up. So everybody answered, except a few, everyone answered option B. Everybody answered option B. Let's see what is this. During short circuit test, the iron losses of a transformer is negligible. Iron losses of the transformer is negligible because we know core losses are proportional to B max. Sometimes B max, but that depends. Or to be more precise, core losses are function of B max, maximum flux density. So if the voltage is less during short circuit test, as somebody is saying, during the short circuit test, you'll be applying less voltage. During the short circuit test, you'll be applying less voltage. As the voltage is less, core losses are less because B max itself is less. Core losses are less. So you can pretty much ignore it. As somebody said rightly in the chat, I think, who is that? Let me just see. Low voltage is required. Sampath has said absolutely right. So, yeah, great. So as the voltage is less, core loss will be less, so you can ignore them. Okay. Now, question is, I asked you in the previous video also this question, I think, yeah, this one. Why OC test is conducted on the low voltage side? I got one answer from Durga Prasad. He's saying low voltage side core losses are less. That's what his statement. Anyone else? Why open circuit test is conducted at the low voltage side? Tell me. See, this is going to be amazing. Mostly people doesn't know about this. Okay. We have a video of that. On the YouTube as well. You can check it out for the full video. I'll try to give the gist of it. Because of the cost, sorry dear, it's not exactly right. Low voltage meters are easily available. This is one of the common most circulated answer which is not correct. This is the answer mostly circulated in the industry which is not correct. Okay. So Krantikumar, he's saying something, it can be partly related. I'll explain what Krantikumar is trying to say, or you can see in our YouTube channel also. Okay, let's see why it is connected, why the test is conducted at low voltage side. Simple logic, it's a logical thing. It's a logical thing. If you have a practical understanding of the things, you will be able to answer it. I have a laboratory. PiSquare laboratory is there. In the PiSquare laboratory, the input voltage to the PiSquare laboratory is 230 volts. But my requirement in the PiSquare laboratory, one of the equipments requires maybe a 2300 volts supply. One of the equipments require 2300 volts supply I require. The input I have is 230 volts. So I have purchased a transformer with 1:10 ratio. Now I am giving this input 230 to this. I am getting 2300. I am fulfilling my requirement. Now suppose, guys, careful. Suppose if I want to test this transformer, which test? No load test. I want to conduct a no load test onto this transformer. We know for the no load test, I will have to give the rated voltage. Nowadays it's a digital meter. You connect the digital meter, range will automatically adjust. Availability of meter is not a big aspect here. Understood? So I know no load test should be conducted at a rated voltage. I want to test this transformer. In order to test this transformer, if I want to test the transformer at the low voltage side, I will have to give 230 volts. If I have to test the same transformer at the high voltage side, I need 2300 volts. Arey bhai, my laboratory does not have 2300 volts. That is why I purchased this transformer dabba. Now to test this dabba, the dabba requires 2300 volts. Where do I have it? To test it, I'll have to buy another transformer. That's the most stupid thing. So why to conduct the test at the HV side? Conduct the test at LV side. It demands the regular 230 volts, what we already have it. I will use it. Did you understand the point here? This is the reason, because the availability of supply don't have the high voltage. That's why I purchased this high voltage dabba. So to test this, I don't have that high voltage. Understood? Meters, akkar, bakar, all these things are like, some crazy people make up answers. Dabba means transformer box. Okay, transformer box. Dabba means transformer. We apply rated voltage on the LV side, more convenient as compared to the. It's not about a convenience, it's about availability. I don't have a high voltage available. Usually it won't be available. Okay. Anyways, this is one of the main reasons. Okay. I know most of the people will differ about it. Okay, I'm open for discussion. Transformer will feel, it's hamara dabba. We have transformer is the heart of electrical engineering, entire alternating current system. Okay, we love transformer the most. I love the transformer the most. Okay, so जहाँ पे प्यार है वहीं से ऐसे होता है बात. इस प्यारी नाम है. That's my lovely name, डब्बा. It will not feel bad. Okay, because I know it's my darling. So don't worry about it. It will not feel bad. Yeah, we got an answer for this. We are moving to the next question. Bang on. Yeah. Yeah, pet name. My pet name is Transformers. Pet name is Dabba. But amazing Dabba, which is a heart, man. I think in our course I said, it's not I said, William Alexander ne bola. William Alexander ne said, William Alexander? I think William Alexander, yeah, he must have said, transformer, the heart of alternating current system is a transformer. Like I'm just quoting his point, which is absolutely true. I do believe that. Okay, you too love it. But मेरा प्यार बदल गया. I changed my love. I changed my girlfriend from machines to right now. My love is what's my love? I missed it. Earlier, I think till a couple of months back, my love was control systems. Right now, actually, to be frank, my love is with AI. Okay, we are loving this AI. Guys, let me ask you a question. Among all of you, I think let me give a poll. Let me give a next poll. In the next poll, I lost something serious, which is important for you. Okay. Hello, sir. How are you? I'm doing great. आप कैसे हैं दिवाकर? Okay, our time's up. I missed it. Now let's look at the answer, guys. Let's look at the answer. Let's look at the answer. The iron losses of a transformer at 400 hertz. Careful, it's a simple one. Everything is given in here. Every detail is given in this. You don't have to use extra knowledge. Whatever is there, if you use that, you'll get the answer. The iron losses of a transformer at 400 hertz is 10 watts. Assuming the eddy current and hysteresis losses vary, assuming that eddy current hysteresis losses vary as a square of flux density. The iron losses of the armature. See, they're saying eddy current and hysteresis losses combinedly means it's a iron losses or core losses are proportional to B max square. It is given in the statement within this bracket 1. The iron losses of the transformer at the rated voltage. Now, this is proportional to B max square, and iron losses at 400 hertz is 10 watt. We know Bmax means what is Bmax? Everyone in the chat, bang the chat, kill the chat. Yes, you're right. Bmax means V by F whole square. Absolutely right. Voltage is maintained constant, so I can ignore this. I can keep it in the constant. Iron losses are proportional to frequency square. It's not, I'm saying it is a question statement itself is saying that. Question statement itself is saying that. Now, frequency has reduced by 8 times. So definitely this will increase. So this is wrong answer. Increased by how many times? 8 times? No. 8 square times. 8 square times. Mane की? Mane 640, 640. 640 watts is the answer. Are you guys clear with this? Simple question. Not 64, 640. Madhu Teja, kya hua? What happened? 64 times. Yeah, you should have given that completely, buddy. Okay, next, guys. Uh, so right now, how many of you, I repeat, right now, how many of you are looking for a job, any job, not necessarily a government job, maybe a private job or anything? How many of you are looking for a job? How many of you really need in a job? A, B, tell me. Just mark it A or B. Just give A or B so that I'll see how many of you are actually in need. So accordingly, uh, we will plan something. We'll plan something. We'll talk to some recruiters regarding this. So we have 26 people right now live. It will be great. Yeah, core job, definitely. I'm talking about job means not a software job, core job. Okay. By mean job, because we are having core jobs only. Okay. How many of you are looking for core job? Option A, option B. Uh, okay. So mostly people are looking for it. Sure. Then fine. We'll see something. Okay. Okay, guys. Thank you for responses. Let's go to the next question. Sir, I got in. Great, dear. Great. Congrats. Congrats, Sai Datta. Coming to this, let's see how many of you answered this question. Nice. Great. Yes, time is up. Time's up. Let's see. The voltage applied to the HV side of a transformer during a short circuit test. Yeah, by the way, uh, I'm saying, right? I think some of you tested PiSquare AI chatbots also. I think in couple of just maybe in 24 hours or so, our bots will be able to solve the questions also. If you just feed the questions, they will be able to give the solution also for that. Okay. So that training is happening right now. It's all training is happening. Backend people are training the bots. So yes, you can expect if you just suppose you have this question, just ask this question to the bots. They will give a perfect solution. Okay. So right now backend training. I tested this particular question. What kind of answer it will give? It gave an amazing answer. Okay, detailed step-by-step answer. Yeah, it's mind blown. Yeah. Okay. Now coming to this question, the voltage applied to the HV side, because what I felt was, of course, we're training people also, we're training students as well, but we enjoy training that bots as well, because feed the inputs, it will completely absorb. The bots are so are intelligent enough to understand what we are talking to the bots. Okay, so it's as good as teaching to the students. If it is to maybe hundreds of students, maybe he'll secure a position and he'll go to the job, he'll go for his livelihood. But if we train our bots, they are there with us. As long as we pay them, they'll be there with us. They'll be keep on answering your questions. So these bots are just for you. Okay, it'll be coming up. We just gave a trial launch to some of the people. They're trying it. Some people are happy about it. Okay, some people are asking some fancy questions. Some people are asking nice questions. They are giving nice replies also. So shortly, these questions also you will be able to ask in that bots. Anyways, the voltage applied to the HV side of a transformer during the short circuit test is 2% of its rated voltage. Now, the core loss in terms of rated core losses is how much? You are applying during short circuit test, you are applying a low voltage. You are applying a low voltage. Are you changing the frequency? You are not changing the frequency. Frequency is constant. Frequency is constant. Just now we said core losses, and it's all about core losses and Bmax. They're proportional. Iron losses or core loss, you can say anything. Okay, iron losses or core losses. Bmax square, sorry. Now the moment I replace this with V by F square, where F is also constant because I'm not changing the frequency during the short circuit test. So iron losses are proportional to the voltage square. Iron losses are proportional to the voltage square. The input voltage is just 2% of the rated voltage. So the iron losses will be 2% means it's 0.02. 0.02 square. How much? 0.0004. This many times of rated iron losses. This many times of rated iron losses will be occurring in this, which means 0.04% of rated iron losses are incurred in the transformer when the input voltage is just 2% during short circuit test. How much is the iron losses are occurred in this? Just not 4%, which is pretty less. This is the reason why we ignore the iron losses, because their value is tiny. We're ignoring it. Okay, I think you got that point also clear. Shall we go to the next question? Yeah. Wow, good. 2 answers. Tritesh is back after a long time. Time's up. Time's up. We got answers in a mixed fashion. Some are given nice answers, some are still confused. Vikram has said option C. Okay, let me clarify, Vikram. Good try, everyone, good try. Let's see. During a short circuit test, just now we have seen the iron losses are negligible because I'm applying to allow the rated current, maybe I require maybe 2 to 4% of the rated voltage. As the voltage is less, Bmax is less, because Bmax is proportional to V by F. As voltage is less, Bmax is less, means flux maximum is also less. Flux maximum is less, so iron losses are less, as mutual flux is a small. That's it. Okay, that's it. Next question. Here you go. Wow, Tarun is saying B or C means we'll have to check it out. Guys, careful here because we got some mixed answers. So I would like to explain this little details. The primary reason why open circuit test is performed on the low voltage winding of a transformer, I just discussed in the first question. One of the requirements is, one of the reasons is, the main reasons is, it requires least voltage to perform the test, which is available in the laboratory to test it. If it demands high voltage, I don't have that high voltage available in the laboratory. So this is the answer. Now, some people are also addressing this. When you are giving supply to the low voltage, the power core losses will be less. That's wrong answer. Why it is wrong answer? Core losses is a power. Forget about the what is this power factor, because in case of core losses, they're mostly towards, forget about the power factor. I mean, for now, losses, we're talking about loss component means resistance component we're talking about. During that aspect, it is voltage and current involves here. Voltage and current involves here. As you're conducting the test on the low voltage side, naturally current will be high current, right? So product will remain the same. So point what I want to make is, whether you conduct the test on the low voltage side, you are allowed to conduct test on the high voltage side also. If the high voltage is available, you are allowed to conduct, no objections at all. You conduct it, you will get the same meter reading. Here power, low voltage side power, high voltage side power will be same. Means iron losses when you conduct here it is same, because the core is same after all. Okay, so you can try it out in your laboratory and test it. So this, I think you got a clarity on this. Give it a thumbs up if you got a clarity on this. Come on. Yes, good, nice. Let's go to the next question in this. I think this is an easy one. Everybody answered it. Superb. Guys, this question, voltage regulation curve, transformers, power systems, synchronous machines, the same voltage regulation curve you will see. You have to keep this curve in your head. Even in DC machines also you will get the voltage regulation in terms of definition if you see. Okay, So here this is lagging or leading. Lagging or leading? Tell me. Lagging or leading? In the chat. In the chat. In the chat. No chat? What happened? Others? This is answering. Others? Others? Let's shower. Let's shower this answer. I want you to answer continuously so that we'll see some raindrops. Yeah, faster, faster. It should fill the screen. The screen should fill with your answers. Lagging or leading? I think you are not doing that, huh? Pour some laggings or leadings your answers. Pour some answers from the top. Drop some answers, guys. I want to activate you all. Good. Per unit voltage. वाह क्या बात है. At UPF is equal to Sai. You're amazing, man. This is for Sai. It's too slow, guys. People are like, slowly, धीरे धीरे कर रहे. Anyways, let's keep it easy. Good. It is lagging. This is lagging. This is leading. Because why I'm asking you to go for this is because this is an important one to answer a lot of questions related to voltage regulation. Okay. So here somebody Sai is saying this is equal to per unit. If it is a per unit voltage regulation, this value will be equal to per unit resistance, and this value is equal to maximum voltage is equal to how much? This is equal to per unit impedance. At what value you will get this? At what value you will get 0? At what power factor you will get this? All are known to you. Now the question is about when it is a negative voltage regulation, means this is negative voltage regulation. That is true only when it is leading. Only when it is leading means 0 power factor, 0 voltage regulation occurs at somewhere close to somewhere between 0.8 to 1 power factor leading. Okay, great. If this is great, let's go for the next great thing. Nice, good responses. Madhuteja is saying voltage regulation is equal to voltage change in the voltage from no load to full load by wow. Guys, Madhuteja has given amazing answer. Amazing answer. He said no load voltage change in voltage from no load to full load by, people will say no load or full load. Instead, Madhuteja is saying it's a rated voltage. You're absolutely right, dear. Perfect answer. According to international standards, wow, rated voltage of a transformer is no load and other it's a full load. Nice, nice, good, keep it up. Wow, Pavitra has answered it, everyone else has answered it. Because I have just discussed this question. I have just discussed this question. Fresh question. That's where, when you're practicing the question, you just don't look at only that option A, B, C, D. You expand your mind to other concepts also. That's where you'll get to learn. You're here to learn. Now, when no load test is carried out on 1000 by 100 volts transformer with 120 volts winding open, means you are conducting this no load test. See, you are conducting the no load test. You are giving the supply to the 1000 volts. Under that condition, the wattmeter, the power losses are showing 110 watts. If the same test is repeated with 1000 volts open, no crime in that. You can do that. You can pretty much do that. Means you are conducting the test on the low voltage side. Then what is the power losses? Same power losses, because same core, same transformer, same rated voltages you are applying. So answer is the same. Not shame, it's the same. Okay, if it is that easy, next question will be double easy. Uh, Ramesh is asking something about answer zero or leading, sir, or both. Okay, we'll go to that, Ramesh. After this, we'll go back to that question. I think most of you answered it correctly. I think everybody marked as C. Amazing. I think in this session, for the second time it happened, maybe everybody is onto the same answer. Correct answer, that too. The transformer has iron losses equal to W1 watts, full load copper loss equal to W2 watts. If two such transformers are tested in back-to-back test, I want you to respond in the chat once again. Respond in the chat once again. What is the other name of this back-to-back test of a transformer? Transformer back-to-back test, other name. Tell me in the chat. Do you know or not? Do you know or not? Yes. Yes. You are right. Hopkinson? Hopkinson test is for, this is for DC machines. Okay. Yes, others? Heat run test, man, come on. Sampanar's test, heat run test. You're absolutely right. You're absolutely right. Somebody saying DC, heat run test, temperature run test. Can you call it as a load test? Not exactly, but yeah, no harm in that. Tritesh. Okay. Sampanar's fine, guys. Smart, great, superb, fantastic. Indirect test. It's a method, indirect method of testing. Load test. Okay. Okay. Great. Great responses. Guys, I just want to know your location. Where are you from? आपका location कहाँ है? Your location? You are from which place? World map is, yeah, okay. Go on. So mostly a map, our AI map says Andhra and, oh, some people are saying Saudi, okay. Fall in love with PiSquare AI. Me too, buddy. We're enjoying a lot. Okay, okay, great, 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 great. Let's get back to our question series. So this is also called as a heat run test. You're right. There is a reason why it is called as heat run test. It's a beautiful reason. OC test, SC test has some limitations. That is an indirect method. OC test, SC test is indirect method of testing. Okay. But back-to-back test is, it's one of the, it has some disadvantage, OC-SC test. So we're using, of course, Sampana test, back-to-back test, also indirect test. But it is overcoming the disadvantages because the heat generation in the transformer cannot be found out if it is OC-SC test. That's why connecting back-to-back test, or it is popularly called as Sampana test. Anyways, its full load current is flowing. The total input is, if you know this back-to-back test, as you're connecting both the transformers back-to-back, the power actually required. Both transformers are running at full load conditions. I repeat, both transformers are running at full load condition, yet they will consume no load power. Yet they will consume no load power. That's the beauty of this Sampanat test. Amazing, man. Let's give it that hard button to amazing Sampanas, the great Sampanas, who has created this is a thought, man. It's not about the bloody test. It's about his thought. Amazing thought. Give it that heart for, smash that heart for Sampanar. Okay? Such a beautiful thought, baby. You can't imagine that. See, you're running the transformers at full load, both the transformers at full load, yet they're consuming only no load power. How many transformers are there? 2 transformers are there. Not no load power, no load core losses plus full load copper losses. Only loss components they're consuming from the inputs, but they're operating at full load. As you have 2 transformers, each transformer has a loss of W1 plus W2 according to this. This is a copper loss, this is a core loss. Now you have 2 such transformers, so total input power taken is 2 are identical transformer. That's why you should take identical transformers. The total input is 2 times of W1 plus W2. Answer is C. Answer is C. Okay. Now somebody is asking some question. Is it there a zero lagging leading? Somebody is asking. Someone has a question. It's a zero for the voltage regulation. Are you there, buddy? Power input is equal to power losses plus power output, but here power output is also zero. The total input loss. Wow, kya baat hai? Badhiya. Great explanation. Okay, let's go to the next question. It's just a repeated question. Yeah, you can go for this one. Guys, careful. This is one of the practical questions. If you are in a hurry, you will be trapped. There is a trap. There is a trap. There is a trap. There is a caution. Careful. Carefully answer this. Let's see who is going to answer this correctly. How many of you are going to answer this correctly? I'm pretty sure most of you people will commit a mistake here. Because, I'll tell you why the reason. Because, answer this, then I'll tell you the reason. This is amazing piece, man. Amazing piece. वाह, क्या बात है, क्या बात है. I loved your response. At least some people responded nicely. Irrespective of their right or wrong, they gave a nice attempt. Thoughtful attempt. I loved it. Amazing, yaar. Keep it up. Keep it up. Ramesh is here about the negative regulation. Okay. Your time is up. Great, guys. I must appreciate because most of you are correct. Answer is C, not A. Careful, I'll explain. This is one of the common confusions. 2000 by 200 volt transformer is fed from a 2000 volts. So immediately we'll think 2000 volts. So output is 200 volts. Zing zing, amazing. No zing zing, no amazing. Why? Because this rating, you think it is a V1 by V2, means input voltage to output voltage ratio. You think like that. That is wrong. It is actually E1 is to E2. It is E1 is to E2, induced primary or induced high voltage to induced secondary or induced low voltage ratio is this. So you are giving a transformer is capable of taking 2000 volts. If you give 2000 volts, it will produce here 200 volts. It is its capability. You are giving how much? You are giving 2000, but as per its equivalent circuit, there is some series branch impedance. You are giving 2000, this voltage you are getting less than 2000. So the induced voltage is less than 200. Then again there is some series voltage drop because it is under rated load. So here voltage will be much less than 200, not much, comparatively less, I mean. So you are giving input as 2000. Here it is less than 2000, hence proportionally here. Again there is a further reduction here. So answer is about 195, not 200. Such a beautiful question. People will ask these questions in interviews also. If you fail to answer, you are gone. You're gone. Provided lagging power factor? Why provided lagging power factor? Okay, you're right. Sai, clap for Sai, man. He is amazing. Provided lagging power factor. Why provided lagging power factor? He said amazing point. It is because positive voltage regulation, right? Regulation is positive, then if it is a negative voltage regulation, it will be more than that. Wow, superb point. Clap means heart. Press that heart for Sai. You're right. You're amazingly right. Nobody is cheering up for you, buddy. But we'll cheer it up for you. Blast for Sai once again. Blast karo bhai. Karo. Okay. Anyways, this is done. I think let's wind up the session. Ramesh is having a query. About this voltage regulation. Let me just go to that. We have few more questions, but lack of time. We're discussing a lot, right? It's not about question to answer. Discussion also matters here, because question to answer. If you want question to answer, within one go, you can have a period test. Hundreds of questions you'll get in one go. But here explanation is important. Beyond that, surroundings are important. For that, we're discussing a lot. Yeah, Ramesh, if you're there, ask me a question, my dear. If you are there, it is said 0. Power factor is 0. So Ramesh is saying, I think Ramesh is saying option will be either A or C. This is what Ramesh is trying to say. Guys, what is your comment? Is it for this question only A, only C, or A or C both are correct? Come on. Please explain copper loss in HV is equal to copper loss in LV. I think these explanations are already given in the course here. It's not, wow, it happens in a minute. They're in the course, or you refer to any book, you refer to any course, maybe free course on YouTube or paid course at anywhere, you will get this clearly. Sir, confirm negative voltage regulation is 0 power factor or leading power factor? So I just want an answer. Don't give the description here. Answer is only C or A and C. That's it. That's what I want to see. Only C or A and C. What is your comment? Look at the question. Because Ramesh has raised it nicely. Okay. So let's see, because that question he raised is good. I want to see your opinion before we wind up. Madhuteza has said only C. Others? Not copper loss. CU in LV, CU in LV. Okay, Sai, I think I'm not getting question maybe. ARC when I saw, but option must be okay. Guys, it's a simple one, yeah. I don't know why you got confused here. See, this here power factor is how much? Tell me. Here power factor is how much? It is unity power factor. This is zero power factor lagging. This is zero power factor leading. Zero power factor does not ensure, will not ensure negative voltage regulation. Zero power factor leading ensures negative voltage regulation. So zero is not a full answer. Okay. And you're right. Every leading power factor will not give negative power, negative voltage regulation. I repeat, every leading power factor will not give negative voltage regulation. But the question says, when load power factor is under what conditions? Tell me when this negative voltage regulation can happen with respect to power factor. Okay, zero means it is not said zero leading. If it is said zero leading, I would have opted for this. It is said zero leading or lagging. Ambiguity, I cannot pick it up. Leading, yes, during leading, yes, it is there. So you have to be smart enough in picking up these kind of things. Anyways, I think you guys are doing pretty well. Okay. So, okay, guys, that's it. That's end of today's session. We had an amazing participation from all of you. Please see my question. What is the question, dear? Sai. Copper material. Please explain. Copper in LV is equal to copper in HV. Copper material used in LV is equal to copper material used in HV. Copper material, weight of the material, if you see, will that be equal? Length and area is a volume. Anyways, we'll discuss that in the next lecture. Amount of material. We'll see that. I don't find there is an equivalence there. Okay, because length and area both are the concerns over there. Length is increasing, area is reducing, so it is. Anyways, we need to have a discussion about it. Okay, so we'll discuss definitely that in the next session. Okay, great. So let me wind up this session over here. Okay, as I said, as people are looking for some job opportunities, we'll see what are the possibilities. Not sending one person or two persons to the interviews for the job, as one person is already went, he's on the way, I think. We'll see how to pull up bunch of people for the jobs. Okay, we'll look for the person, because as we saw your interest today, we'll plan for it. And for that, one of the conditions will be definitely there. I said already, I'm completely biased towards PiSquare students only. Okay, means you must have taken some video course or the other. Otherwise, you will not get into that eligibility criteria. Okay, and if you want to check our courses, free videos also available. Okay, you can check courses.pito.in the website. Online test, different individual packages, or combined packages for different exams. Everything is over here. Okay, so you can check it out. You can get the courses. If you have any queries on regarding any course purchase or anything, you can ping on WhatsApp. Our WhatsApp is scrolling in the down or in the description is there. Just click there. Our team will take care of it. Okay, so all the best. Happy learning and enjoy the learning in PiSquare style. Bye-bye.